Okay, the last video before your test, 5.5, bases other than e. So that's the derivative and the integral of exponential functions in the form a to the x, where a is a real number, just not the number e. Alright, so last lesson we looked at the derivative of e to the u. The derivative of e to the u is itself times the derivative of the exponent. The derivative of a to the u is itself times the derivative of the exponent. But now we need to multiply by the natural log of the base of the function. Go backwards real quickly. What's the natural log of e? It's just equal to 1. So that's why we don't need that extra condition when we derived e to the u. So you'll see me, or hear me as I'm using it. Natural log of the base times the exponential function times the derivative of the exponent. The antiderivative of e to the u is just itself plus c. Remember what I said in the video we looked at in class? The most difficult part is identifying u and making the correct substitution for du. The antiderivative of a to the u is itself plus c, but now we have to divide by the natural log of the base. Okay, go backwards, think about dividing by the natural log of e. That's just dividing by 1. That's why it's not needed with e to the u. Alright, now this one is a little bit different. The side work for this, log base a of u. Way back when you learned the change of base theorem. And the change of base theorem said when the base of a log was not e and not 10, you change the base by taking the log of the expression divided by the log of the base. Alright, I'm going to change the base. Instead of changing it to base 10, I'm going to change the base to base e, because we know a little bit about the natural log function now. Okay, so I changed the base. These two things are equivalent. Now what I'm going to do is take the derivative of this function with respect to x. Natural log of a. A is a real number, so 1 over ln of a, that's just a constant. The derivative of the ln of u is 1 over u times the derivative of the expression. So this is our derivative rule for log base a. So the derivative of log base a would be u prime all over u times the natural log of the base plus c. This one I feel is the one that can sort of get away from us a little bit, but we'll just continue to use it so you guys are comfortable. Okay, now let's put them to use. Find the derivative. So r prime of w. The derivative of any exponential function is itself times the derivative of the exponent, but now because the base is not e, we have to multiply by the natural log of the base. Minus 5. 5 is just a coefficient, it stays put. The derivative of log base 9 of w would be w prime, so the derivative of w would just be 1 over the expression w times the natural log of the base. Now as far as writing this, maybe we'll keep it as ln of 12 being multiplied by 12 to the w, just so you guys don't confuse the two 12s. As we learn more derivative rules, I continue to say it. The answers don't look nice, but they're answers nonetheless. Don't let the w's here confuse you. They're just the variable used instead of an x. Alright, so the derivative of this function, f prime of x, 3 is a coefficient, derivative of e to the x is itself, 10 is a coefficient. Now for x cubed times ln of x, we would need the product rule. First times the derivative of the second, plus second function times the derivative of the first. Okay, so 3e to the x. I'm going to distribute the 10 and simplify when needed. So these would cancel. So I have 10x squared plus 30x squared ln of x. Nothing can be factored out of all three terms, so we can just leave the derivative as the sum of those three separate terms. Okay, so I'm going to use my derivative rule for, it should be a to the u. So y prime, natural log of the base, times the exponential function exactly as is. Now I need to multiply by the derivative of the tangent of e to the x. That's u. That's my exponent. Chain rule, working from the outside in. Derivative of tangent is secant squared of the expression. Derivative of e to the x is e to the x. And as far as rewriting it, we can really just leave it as is. Maybe, so we have ln of 9 times e to the x times 9 raised to the power times secant squared of e to the x. Sorry. Should have moved that down a bit. And this is not multiplied, but the exponent. So e raised to the x. Alright, now let's look at some integrals. So what are our integral rules? A to the u is itself divided by the natural log of the base. Okay, so where will we start naturally for u? Let u be the exponent. So du would be negative dx. Making my substitution, I would have 5 to the u. Dx is equal to the opposite of du. So that brings a negative out front for me. The antiderivative of a to the u is itself divided by the natural log of the base. And just the last step, make that replacement in terms of x and add the c to it. Remember, you can always check your antiderivatives by deriving the answer we get. Okay, the derivative of this, negative 1 over ln of 5 is just a coefficient. So now when I derive the exponential function, it's itself times the derivative of the exponent times the natural log of the base. And we know the derivative of c is just 0. So check out all these things that cancel. Ln of 5, ln of 5. Negative 1 times negative 1 is positive 1. So what are we left with? The original integrand. Okay, a lot going on here, but don't lose the 7. 7 raised to the 3 minus x quantity squared power. So let's start with the exponent always, the entire exponent. So using the chain rule, du would be 2 times 3 minus x to the first power times negative 1. Okay, that would be the derivative of the inside. So I have du divided by negative 2, 3 minus x is what I'm going to replace dx with. So 3 minus x times 7 to the u times du divided by negative 2, 3 minus x. So my binomial cancels. I bring a negative 1/2 out front. And now we have our antiderivative is itself divided by the natural log of the base. So now let's just replace u to be in terms of x, 2 ln of 7, and then we add c to the answer. So the derivative and integral rules are not difficult, they're just, you're learning them all at once. It's hard to keep them straight. Okay, same deal, I see an exponential function, so I'm going to start to pick my u as the exponent. So the exponent is sine of x, the derivative of sine is positive cosine. So I have 2 to the u, cosine x dx, I replace that entire thing with du. It's a nice simple substitution, nothing needs to be introduced. So 2 to the u divided by ln of 2. I'm going to replace u as sine of x and add c. Alright, let's look at a definite integral. Okay, u would be x over 2, which it's my exponent, which makes du 1/2 dx. So 2 du is what I'm going to replace dx with. Alright, I'm going to do it two ways. The first way, you'll see. Alright, -2 to 2, 4 to the u, dx gets replaced with 2 du. Make sure you're not multiplying that 4 and 2. 2 comes out front. Alright, so I have 2. Antiderivative of 4 to the u is itself divided by the ln of 4. And then I need to not write that so big. I'm going to write it as 2 over ln of 4. That's all coefficient. Replace u with x divided by 2, and now evaluate that function from -2 to 2. So 2 over ln of 4. I have 4 raised to the 2 divided by 2 is the first power, minus -2 divided by 2 would be 4 to the negative first power. So 2 over ln of 4, 4 minus 1/4. Okay, common denominators, this would be 15, this becomes 15 over 4, so I would get 30 over 4 ln of 4. Alright, my second option, at this step, so u substitution is the same. I'm going to replace my boundaries to be in terms of u as well. So when x equals 2, going back to my u substitution, u would equal 1. When x equals -2, u would equal -1. So check out what's happening here. When x is 2, u is 1. When x is -2, u is -1. So my boundaries are still low to high. Same antiderivative. But now I don't need to replace my exponent to be in terms of x anymore. My boundaries are all in terms of u. So 2 ln of 4, I have 4 to the first minus 4 to the negative first. So I hope that you guys continue to see, no matter which method you choose, and I will not tell you which one to use, you get the same answer. Alright, find the derivative of this function. So we got all sorts of things going on here. I am going to rewrite as much as I can. Okay, so 2 is a coefficient. I'm going to take out the 1 dividing by t is multiplying by 1 over t. Then I'm going to use my change of base here. Alright, I'm going to rewrite this as the natural log of t divided by the natural log of 4. So I changed this logarithmic function. Instead of being base 4, I changed it to base e. ln of 4 is just a number, so I'm going to bring the ln of 4 out front. And now my function is ln of t divided by t. So I would have needed the quotient rule no matter which method I chose, whether just to dive into the derivative or rewrite it first. So I opted to rewrite. G prime of t, 2 over ln of 4, that's a coefficient, it stays put. Bottom times the derivative of the top, minus top times the derivative of the bottom, all over bottom squared. These cancel. So my numerator, 2 times the quantity, 1 minus ln of t. My denominator, ln of 4 times t squared. Okay, so for homework, our next class, please complete these 3 problems. Those of you that print the slides, these are on slides as well. 1 integral and 2 derivatives. Your last derivative, you'll need logarithmic differentiation. I'll see you in class.